Okay, welcome back to Unit 9, Day 2. We're doing polygons on the coordinate plane. So the first video focused on triangles. This second half of this lesson focuses on our quadrilaterals. So if you remember some of our characteristics of quadrilaterals, we have certain types of parallelograms, rectangle, rhombus, or square, and then we're going to talk about trapezoid and kite. So I'm going to get right into this. First thing it says, we want to know, is RSTU a parallelogram? If it's a parallelogram, we need opposite sides equal. And we need opposite sides parallel. So just a reminder, the parallel symbol looks like two straight up and down lines. If you ever see me, it looks like the number 11 if you see that written. All right, so to find the lengths of the sides, we're going to show what is the length of RS by using the distance formula. So it's x2 minus x1, so I'll do 2 minus 1 squared, plus we'll do our y's, 8, oops, I did not mean to touch that. 8 minus 5 squared. So we get 1 squared is 1, plus 8 minus 5 would be 3 squared is 9. So I get square root of 10. Okay. Square root of 10 is about 3.2. Then we can do, we'll do ST. Let's see, if I do the x's, I would do 8 minus 2 squared, plus the y's, 4 minus 8 squared. 6 squared is 36. 4 minus 8 is negative 4, but when you take a negative times a negative, you get positive. So positive 16 equals the square root of 52. And that is about 7.2. So we want to see if we do the other two, if they come out the same. So I didn't write it down, but if I continued to do the same thing, let's say, is RS going to be congruent to TU? Trying to figure out, is this a parallelogram? So TU would be 8 minus 7, or you can do 7 minus 8. Since I did 8 minus 7, I'm going to have to go 4 minus 1. We get 1 plus 9 equals square root of 10. So these two are for sure equal. So let's try the other side. RU. Is that one going to be equal to this one? So R to U would be 7 minus 1 squared and 1 minus 5 squared. That gives me 6 squared is 36. Negative 4 squared is positive 16. So it did come out to square root 52. So those two opposite sides are equal. Okay. Now we're going to prove that opposite sides are parallel. So we want them to have the same slope. Okay. So let's do the slope of RS. You can count on your picture. 1, 2, 3. It goes up 3 over 1. So rise over run. Or you can use the slope formula. I just thought, for this sake, I'm just going to say the slope of RS is up 3 over 1. Okay, so that slope could be 3. If I want to check this one, 1, 2, 3 over 1. This one goes up 3 over 1. So TU is also 3 over 1, rise over run. We'll go with, to get to S to T, this time, we can do RU, I guess, it's easier. S to T. We're going to go down and then over. So we have to go down 1, 2, 3, 4. So ST is -4. You're going to go down 4 and then over 1, 2, 3, 4, 5, 6. Okay, let's see if we get the same thing when we go from. Get rid of those extra lines in there. Okay, let's see if we count from R to U. 1, 2, 3, 4. Okay, that was down 4. Let's count over. 1, 2, 3, 4, 5, 6. So it looks like those two come out the same. So we have, on both of these, opposite sides are parallel because parallel lines have these same slopes. Same slopes on parallel lines. All right, so this has you try it without a picture. If you don't have a picture, you might want to go back and use this slope formula for finding slopes. So we want to check, it says what type of parallelogram it is. So because it wants what type of parallelogram it is, we can assume that opposite sides are already parallel, and we can already assume opposite sides are congruent. Now we want specifically just to know which one it is. So we're going to start off by drawing a picture over to the side. I have no idea what it's going to be yet. So let's say if we don't know what it's going to be, we'll just draw it like a square. Pick a corner to start at and just call it A, B, C, D. Go around the shape. So we want to prove, to see if AB is going to be the same length or different length as BC. Okay, so you want to look at consecutive sides. So let's find the length of AB. Four minus -2, those are x's, plus the y's would be 6 minus 2. So when you have minus and negative, you can go ahead and cross your line, change your sign. That makes 6 squared is 36. 4 squared 16, so we get square root of 52, which I felt like we've had that one before. You don't even have to square root it if you don't want. Let's try the next side, BC. That's 6 minus 4 squared plus 3 minus 6 squared. Okay, 2 squared is 4. -3 squared, a negative times a negative is going to give you a positive 9. So you get square root of 13. Okay, so if you look at these two numbers, square root of 52 and square root of 13 are not the same. So the sides are not the same. It's going to be either a parallelogram or rectangle. Okay, so now this is why we typically have to keep going to figure out the slopes, because parallelograms and rectangles both have opposite sides equal and not congruent, but one of them has 90-degree corners. So let's see if these lines are perpendicular. So we're going to find the slope of AB. And I can't do rise over run without the picture, so I'm going to have to go back to the old slope formula. 6 minus 2 over 4 minus -2. The y's go on top. So I get 4 over 6, which reduces to 2/3. Okay, so then let's try and find the slope of BC. Okay, these are these 2 points right here. So your y's would be 3 minus 6 on top. Those are your y's. 6 minus 4 on the bottom. So we get -3/2. These are opposite reciprocals. That means they are flipped. Opposite reciprocal means these lines are perpendicular. Perpendicular means they meet at 90 degrees. So the only thing that has opposite sides equal and 90-degree corners is a rectangle. Okay? On a rhombus and a square, all sides would be equal. So just kind of remember that off to the side. We'll say all sides would be equal. And on ours, we found that the sides weren't equal, and that's why we went for those 2 choices. All right, to be a trapezoid, we need one set of parallel lines. So we need to prove there's one set of parallel lines on this, okay? So let's find, to prove parallel, we need the slopes. So let's find the slope of BC and compare it to the slope of AD. And the reason I only picked those 2 is because if I look at this picture, I can tell BA is not going to be the same as CD. So let's try BC. You can use your slope formula. We can subtract y minus y over x minus x. Or you could do the slope counting thing, rise over run, if you want to count this. Go up 1, 2, 3, or 3 over 6. 3 over 6 that way. That's really not a good showing. Let's try a different color. You can go up 1, 2, 3 over 1, 2, 3, 4, 5, 6. So 3 over 6. That's rise over run if you want to do it that way. Or you can just use the points. So y's go on top, 4 minus 3 over 6 minus 4 equals 1 over 2. So I'm going to say yes, one set of parallel sides. We just have to prove that one side, one set is parallel to the other one by proving that their slopes come out the same. On a kite, last example on day 2, on a kite, consecutive sides are congruent. Consecutive sides are congruent. Congruent just means equal. So we're going to do a lot of distance formulas here to see if the sides are the same length. Again, I know some teachers prefer Pythagorean theorem, and you can do Pythagorean theorem to show that the diagonals are the same length, or you can do distance formula. You could also, another way some teachers like to do it is draw in the diagonals and prove that those diagonals would be perpendicular to show that it's a kite. That's another way to do it. You can use those lengths to also, like I said, show that. So we're just going to do length. Find the length to see if the sides are equal. So we're going to compare KL and LM. I think those two look the same length, okay? And then we're going to choose to compare KJ and MJ. We're going to see if those two are the same. If both pairs come out congruent, then I know it's a kite because those are the consecutive sides. So let's start with KL. We're finding the length of these, so we want the distance formula. Oops, not what I meant to do. Okay. So 1 minus 0 squared plus 8 minus 5. A lot of distance formula on these couple days here. That's 1 squared is 1. 3 squared is 9, so I get square root of 10. Okay. We'll do LM. So 4 minus 1, those are your x's for L and M. And then your y's would be 7 minus 8. We have 3 squared is 9, plus negative 1 squared is still positive 1, so you get square root of 10. So right now, I know that these two lengths are the same. We proved it using the distance formula. So now we're going to use the distance formula on K to J. So let's plug it in the distance formula. 4 minus 0 squared plus 2 minus 5. Grouping your x's and grouping your y's. 16. 2 minus 5 is negative 3. When you square a negative, it becomes positive. You get square root of 25. And you can leave it like that, or square root of 25 is 5. Okay, so let's do MJ. Four minus 4, well that's 0. And 2 minus 7. So we get 0 plus negative 5 squared is positive 25. So I get square root of 25 again. So I'm going to put a check mark. These guys are also equal. So to be a kite, consecutive sides like that need it to be equal. So yes, this is a kite. All right, that's everything for day 2. So if you go back to the first video, we looked at using distance formula to classify the sides of a triangle, equilateral, isosceles, or scalene. And then to determine if it's a right triangle, we looked at slopes to show that they were opposite reciprocals. Then we said to prove a parallelogram, we need opposite sides equal and opposite sides parallel. So we did length and slope. To prove certain types of parallelograms, we looked at the lengths and the slope in those situations. Trapezoids, we just needed one set of parallel sides. And for a kite, you need consecutive sides are congruent. That's